Recovery consideration. The retention period is a key consideration for recovery. The retention period for a backup is derived from an RPO. For example, users of an application might request to store the application data from its backup copy, which was created a month ago. This determines the retention period for the backup. Therefore, the minimum retention period of this application data is 1 month. However, the organization might choose to retain the backup for a longer period of time because of internal policies or external factors such as regulatory directives. If the recovery point is older than the retention period, it might not be possible to recover all data required for the requested recovery point. Long retention periods can be defined for all backups, making it possible to meet an RPO within the defined retention period. However, this requires a large storage space, which translates into higher cost. Therefore, while defining the retention period, analyze all the restore requests in the past and the allocated budget. RTO relates to the time taken by the recovery process. To meet the defined RTO, the business may choose the appropriate backup granularity to minimize recovery time. In the backup environment, RTO influences the type of backup media that should be used. For example, a restore from tapes takes longer to complete than a restore from disks. Backup methods. Hard backup and cold backup are the two methods deployed for a backup. They are based on the state of application when the backup is performed. In a hard backup, the application is up and running with users accessing their data during the backup process. This method of backup is also referred to as an online backup. A cold backup requires the application to be shut down during the backup process. Hence, this method is also referred to as an offline backup. Backup methods. The backup of online production data is challenging because data is actively used and changed. If a file is open, it is normally not backed up during the backup process. In such situations, an open file agent is required to back up the open file. These agents interact directly with the operating system or application and enable the creation of consistent copies of open files. In database environment, the use of open file agents is not enough because the agent should also support a consistent backup of all database components. For example, a database is composed of many files of varying sizes occupying several file systems. To ensure a consistent database backup, all files need to be backed up in the same state. That does not necessarily mean that all files need to be backed up at the same time, but they must be synchronized so that the database can be restored with consistency. The disadvantage associated with a hard backup is that the agents usually affect the overall application performance. Consistent backups of databases can also be done by using a cold backup. This requires the database to remain inactive during the backup. Of course, this disadvantage of a cold backup is that the database is inaccessible to users during the backup process. A point-in-time copy method is deployed in environments in which the impact of downtime from a cold backup or the performance impact resulting from a hard backup is unacceptable. The point-in-time copy is created from the production volume and used as a source for the backup. This reduces the impact on the production volume. To ensure consistency, it is not enough to back up only the production data for recovery. Certain attributes and properties attached to a file, such as permissions, owner, and other metadata, also need to be backed up. These attributes are as important as the data itself and must be backed up for consistency. In a disaster recovery environment, Bare metal recovery refers to a backup in which all metadata, system information, and application configurations are appropriately backed up for a full system recovery. BMR builds the base system, which includes partitioning, the file system layout, the operating system, applications, and all relevant configurations. BMR recovers the base system first before starting the recovery of data files. Some BMR technologies, for example, server configuration backup, can recover a server even on to dissimilar hardware.